You just spent 3 months successfully building a complex MERN stack application. MERN stands for MongoDB for your database, Express and Node.js for the server side, and React for the front-end interface. On your personal laptop, this app runs flawlessly. But the exact moment you try to move this application onto a live external server to share it with the world, everything breaks. This introduces the most notorious excuse in software. Well, it works on my machine. For global deployment, local success means very little. You have just entered dependency hell. This is the chaotic reality where a mismatched operating system, a few missing background files, or invisible software configurations cause your code to shatter in its new environment. Successfully running that app elsewhere requires the manual reconstruction of your original computer's exact internal ecosystem, a task that is notoriously difficult to get right. To see why this is so painful, let's look at the traditional manual method side by side with modern automation. First, you manually install MongoDB as your database, configuring communication ports step by step. Next, you layer on Express for your backend logic, manually replicating every single security rule and routing path from your laptop. Then comes the runtime engine, Node.js. If you install version 16 here, but built your app on version 18 locally, that discrepancy silently corrupts the stack. Finally, you compile your React front-end interface and try to wire it into this fragile new backend structure. And then, one tiny human error, a single outdated version number or a missed configuration step, takes the whole system down in a catastrophic crash. Relying on human memory to manually reconstruct dozens of hidden software dependencies guarantees wasted hours and broken applications. Docker solves this by taking a completely different approach. Rather than rebuilding the environment on the new server, you package the environment right alongside the code. Your database, your backend logic, your runtime engine, and your front-end interface are all bundled together into a single unit. This is the container. It is a sealed, isolated unit that preserves the exact operating conditions your code needs to survive. Because this container brings its own dedicated internal ecosystem, it ignores whatever operating system or underlying software happens to be running on the host server. This shift transforms software deployment into the delivery of a fully functional, climate-controlled mobile home, ready to plug in anywhere. The manual method often ends in an endless loop of debugging, while the containerized method is instantly ready. To deploy your complex, multi-layered software to a completely different device, you now just drop in this single container file and run one command. By eliminating the need to carefully configure server environments, engineering teams save hundreds of hours of manual labor. This standardization created a uniform, reliable method for shipping digital products across the globe. Containerization freed developers from playing the role of server mechanics, allowing them to focus entirely on writing code.